Don't forget to subscribe and ring that bell.
Endings are always bittersweet. Oh, the sorrow, but the joy as we finish the last problem on the free response section with free response question number 6 of the 2021 AP Calculus AB exam. No calculator, but don't worry, don't be sad. Those gray skies are going to clear up because we are going to knock this out in the park. You ready? Let's get going. Number 6 reads, a medication is administered to a patient. The amount in milligrams of the medication in the patient at time t hours is modeled by a function y equals a of t that satisfies the differential equation dy dt equals 12 minus y over 3. I am smelling a separable differential equation here, but let's see what happens. Okay. At any time t equals 0 hours, there are 0 milligrams of the medication in the patient. Part A asks or tells us a portion of the slope field for the differential equation dy dt equals 12 minus y over 3 is given below. Sketch the solution curve through the point 0, 0. My God, people, I wish all your problems were this easy. First of all, let's start. The point 0, 0 is right here at the origin. That's the point 0, 0. All you have to do in a situation like this is follow the slants and the curves. Notice I'm kind of going up. It slants a little bit, slants a little bit, slants, slants, keeps slanting until it kind of just eventually goes flat right there. Okay? And that's all you've got to do for part A. My goodness. Whew. Don't mess that up. Don't have a little spasm with your hand when you're writing that. Part B, let's see if it's a little bit more challenging than part A was. Part B says using correct units. Okay, so I'm going to have to label this correctly. Interpret the statement. The limit as t goes to infinity of a of t is 12. We don't even have to do work. Oh my God. So we're just going to kind of interpret this statement right here, this mathematical sentence, if you will, this limit, but we're going to do it in the context of the problem, okay? In the context of the problem. That means we've got to probably reference medication. Okay, I don't know why that's black. We'll go there. Medication, there we go. Milligrams, probably. Hours. All right, and milligrams of the medication still in the patient or in the patient. All right, so that's the context of the problem. So what I would say here that as time goes on, okay, as time goes on, forever and ever, all right, we will never have more, okay, or the amount of medication in the patient will approach 12, okay? It will never hit 12. It will never go over 12. So we've just got to say something to that nature. So, I don't know. I'm just going to say as time continues to increase, right? Because it's going up to positive infinity. The amount of medication in the patient will, and I'm going to write it this way, will approach 12. Oh, that's a funky too. 12, and they say milligrams, right? So we can just do mg if you'd like. Now, I'm going to take a look at this quickly because there are several ways to write this, but there are just things that you need. Okay, as time continues to increase, that's as time goes infinity. The amount of medication in the patient That's what medication in the patient, that's the context of the problem, will approach 12. Limits, okay, that's what our output is approaching, 12. Okay, so you can write it one of a million different ways, but why not write it that way? That's simple. Okay, so 6A is done, 6B is done. Call me a math nerd, but I love separable differential equations. And once I saw this, I just knew we were going to have to rip that y and dy alone and get the dt on the other side. It works beautifully. Part C reads, use separation of variables to find y equals a of t. The particular solution to the differential equation dy dt equals 12 minus y over 3 with the initial condition. Okay, this is where it gets important. Okay, when time is 0, my output, y, is 0. All right, so I am going to absolutely set this up. I'm going to, I'll rewrite this. dy dt equals 12 minus y over 3. The first thing I'm going to do is multiply both sides by 1 over 12 minus y. 1 over 12 minus y. All right. Then the next thing, I'm going to multiply both sides by dt. dt. Let's not forget, there's a 1 still up here when this is gone. So what do we have left when everything is all said and done? We have 1 over 12 minus y dy on the right side, on the left side, I should say, equals 1/3 dt. Okay. At this point, should come to no surprise, we're just going to integrate both sides. Okay. It's going to integrate both sides. Now, you can do u sub if you want. You can do u sub. If you're here watching this, I should probably do u sub. Oh, Lordy. But those of you that know this part without doing the u sub, good for you. All right. If I make u 12 minus y, that means du equals negative dy. So I'm going to multiply both sides by -1. So negative du is going to go in place of dy. So right here, we're going to continue. This is the integration of 1 over u, because we're putting a u in for this denominator. In for my dy is a negation and a du. So ultimately, this is going to give me the ln of u. It's negative out front. And we need to put back in for our u 12 minus y. So it's the negation of the ln of 12 minus y. Okay? And don't forget, it's plus some constant c. I put a c1 there because we're going to have a constant on the right side as well. So for this, right here, this in orange that I'm circling is going to go in its place. So let's start to write that. We have the negation of the ln of 12 minus y plus some constant c equals. All right, well, let's do something simple and integrate this now. That's just 1/3 t. Or if you want to write it, you can say t over 3 plus another constant, okay? T over 3 plus some other constant. The 1 and the 2 that I put with the constants just tells me that these could be different constants. They don't have to be the same constant. You can use, different variables, I guess, to represent constants, but we typically use C. Now, first thing I'm going to do is I'm going to bring this constant over to this constant. The negative ln of 12 minus y is going to equal t over 3 plus, well, if I combine two constants, that's just going to give me another constant. Now I can write C without a sub 1. or a sub 2. All right? Okay, kids. Now, this is the part that I have to sometimes explain to my students. Before I put in this initial condition, I mean, I'm going to get rid of this negative sign on the left side of the ln. And this is the part that I have to sometimes explain. But once I say it 1, maybe 2 times, kids start to get it. I should say students, because they're almost not kids anymore. But if I multiply this side times a negative 1, this cancels, and I have the ln of 12 minus y. If I multiply this side by negative 1, okay, that negates my 1/3, or t over 3. If I make this constant negative, I don't have to flip that sign. I can add a negative c. If I have a negative 3, or a positive 4, or a negative 7, or a positive, these are all still just constants, okay? So I leave it like that, okay? And they should too, and you should as well. Now, before I plug in my initial condition, I like to get rid of natural log because it's going to help me evaluate, especially without a calculator. So the next thing I'm going to do is create a base E for both sides. Goes away. We got 12 minus y. That's a million times easier to evaluate. Equals what math operation if I'm adding exponents? Okay, what math operation did I do if I add exponents? Well, I have to multiply things with similar bases to add the exponents, don't I? That's 2 plus 3, right? 2 plus 3. Well, I have this and this. That means I must have had e's with similar bases. E with a c times e to the negative t over 3. And guess what? Guess what, kids? E is a constant. It's 2.718. A constant raised to a constant, well, I'll leave it there. So if you're looking back, that is just another constant. C e to the negative t over 3 equals 12 minus y. Right? At this point, I am going to figure out what my C value is. Right? Our initial condition was 0, 0. Let us not forget that our initial condition 0, 0 for t and y. So let's go back down here. This part is taking a while. 12 minus 0 for y equals c e. This t right here is going to be 0, 0 over 3. So that means anything to the power of 0 is just 1. 1 times c is c. Therefore, c is 12. I need to put that back into my equation. All right? That is going to go back. This value of 12 is going to go back into c. Okay? Remember, I'm going to have to. This part right here, I'm going to have to solve this for y. They want me to come up with an equation y equals. Now I know what the c value is. All right? So I've got 12 minus y equals my c, which is also 12, e to the negative t over 3. All right? So far, so good. How about we subtract 12 at this point? We're almost done. This is a lot of algebra. So we have negative y equals negative 12 plus 12e to the negative t over 3. And the last thing we're going to do is we're going to multiply both sides by a negative 1. Which means, after all this work, y is going to equal, I'm going to flip this sign to make it a positive 12. I'm going to flip this sign and make it negative 12e to the negative t over 3. That was a lot. I mean, A and B were peanuts. I think this felt even more robust and rigorous because A and B were such easy, light work. So we got to separate our variables and our dummy variables, integrate, and then once we integrate, we got a lot of like algebraic manipulation to do here. And there's your answer. People. This is a lot to read. All right, let's just do it and get it done with. I have a son, and my advice to him anytime he has a difficult task in front of him is just, you know what? The only way to have it be done and over is to just do it. So let's just do this, okay? D reads, a different procedure is used to administer the medication to a second patient. The amount in milligrams of the medication in the second patient at time t hours is modeled by a function y equals b of t. That satisfies the differential equation dy dt equals 3 minus y over t plus 2. Whew. At time t equals 1 hour, there are 2.5 milligrams of the medication in the second patient. Is the rate of change of the amount of medication in the second patient increasing or decreasing at time t equals 1? Give a reason for your answer. Oh, Lordy. Okay, so the first thing that stuck out to me, was the following. Maybe it's important, maybe it's not. Let's see. Is at time 1, there are 2.5 milligrams. This is for B of T. That means B of 1 is 2.5. Okay, so let's just stick that in our back pocket. That is probably going to come in handy. We don't have to worry about A of T. Okay, this is strictly talking about the second patient, which is B of T. All right, so is the rate of change of the amount of medication in the second patient increasing or decreasing? By rereading that, I know exactly what I got to do. Resist the urge to just throw a 1 in here and answer the question. This is indeed the rate of change. However, they are asking you, is the rate of change, which is this thing, increasing or decreasing? That means I need to take my rate of change and take the derivative of it and see what that is. Okay? I am seeing, okay, whether something is increasing or decreasing, that's first derivative. That's slope. That is a basic piece of knowledge you should know. So what am I trying to find the slope or the rate of change of? I am trying to find the slope or the rate of change of the rate of change. Okay, so let's establish that right now. All right, so the first thing we need to do is say to ourselves, okay, well, well, dy dt, okay, dy dt, okay, at time equals 1. All right. I want to see what that's doing. Then I'm going to compare the second derivative, d2y over dt2 at time equals 1, and compare them. It's kind of like when a particle is speeding up or slowing down. All right? So let's take a look at this. This is not our answer. We need to do the second derivative as well. Right? So the first thing I'm going to do is I've got 3 minus, okay, y. Now, isn't y basically the same thing as b of t? It tells us right here. So I'm going to put a b of t. And what time do we want? At time equals 1. All over time, which is also 1, plus 2. So we have 3 minus. What is b of 1? Oh, look in our back pocket what we got. B of 1 is 2.5 over 1 plus 2. So we have 0.5 over 3. No, I lied. Look at me. The 3 is by itself. The t plus 2 is only below the b of 1. So I've got 3 minus 2.5 over 3. Let's just make this 3, 9 over 3, so I can combine these. Because I want to see if this is a positive or negative, and that's 6.5 over 3. That is greater than 0. Okay, so I know that's increasing. But now let's take a look at the second derivative at time equals 1. Let's see how that's going to affect the first derivative. All right? Here we go. So the second derivative. Okay, the second derivative. Let's do this in a different color. I like black and gray, those neutral colors. They complement each other really nice. I've got to take the derivative of this. Okay? Really with the t in there instead of the 1. So the derivative of 3 goes bye-bye. Negative, the derivative of bt is just b prime of t. Okay. All over the derivative of 1 plus t plus 2, I should say. This is t plus 2. The derivative of that, oh my God, it's a low d high, high d low. Oh, let's do this. Let's move this down. You poopy head. Because it's okay. First of all, let's rewrite it. Here's the first derivative. I was doing this like it's sloppy towels. Okay, if I want the derivative of this, that would give me the second derivative. There, I feel more comfortable. It's all right in front of our faces now. The derivative of 3, 0. Minus. I have to do the quotient rule here. It is low, which is t plus 2, times the derivative of the high, which is b prime of t, low d high, minus the high b of t, times the derivative of below. The derivative of that denominator is just 1. I draw a line, and then I square below. Okay, let's clean this up. Now I feel more comfortable. The 0 I don't need. So I'm really going to have t plus 2 negative out front times b prime of t minus b of t all over t plus 2 squared. I want this at time equals 1. I still want this at time equals 1 just like I had the top here. So I'm going to put a 1 in for this t, for this t, for this t, and for this t. Let's go. Let's do this. So we have the negation of 1 plus 2 times b prime of 1 minus b of 1 all over 1 plus 2 squared. All right, so I put my t here, 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 and here. Okay, well, the good news is we know b of 1 is 2.5. So right here, this is 2.5. I know 1 plus 2, well, that's 3. B prime of 1, we just figured that out. B prime of 1, that's what this whole top thing was. Yeah, I'll be okay. B prime of 1 was this whole thing. That was 6.5 over 3. All right? So this is 6.5 over 3. 1 plus 2 is 3, and 3 squared is 9. All right. Ooh, this is nice because the 3's cancel, and I get 6.5. Ooh, minus 2.5. I forgot something in that fraction. Minus. That is going to make a big difference. So we have negative 4 over 9. This is the second derivative at time equals 1. Okay, so let's take a look at these two. My first derivative at time equals 1 was 6.5 over 3. My second derivative at time equals 1 was negative 4 over 9. So are we increasing or decreasing? We were increasing. This was going up. But when this negative affects it, it flips it, it is coming back down. Okay? So I'm going to say decreasing. Let's answer the question. At time equals 1, since dy dt is greater than 0 at time equals 1, and d2y dt is less than 0 at time equals 1. That was the way it was worded. I mean, normally you don't have to take a look at both your derivatives, first and second, unless it's like a particle and they're talking about speed increasing or decreasing. This was a tough problem to just absorb. And I made one or two kind of, mistakes that I caught along the way and adjusted on the fly because I'm trying to go fast in my brain. But we gotta take a step back and slow down. Whoever made a comment that the 2021 exam was different, there were a lot of problems that were similar, but there were definitely some sections, some work that was slightly different that we don't typically see. All right? But it's still good to expose yourself to these types of things because who knows what's going to happen in the 2024. I don't think it's going to be quite this crazy, but I do think it'll be good. It'll be challenging, and it will be doable. Okay? Today is May 10th. The exam is the 13th. Today's Friday. That exam in 2024 is literally Monday. So you have the weekend to get ready. You got this. Drop a comment below. Hey, follow and like me. Yeah, please like me. Please. I'm sad. I will see you guys later. Bye-bye.
Don't forget to subscribe and ring that bell.